You know, there are some things out there that you just kind of get to a point where you just want to take it out in the yard with your grandson and use it for punting practice. And this radio almost got to that point with me. Uh, what can I say about it? I refilmed this this video probably 2 or 3 times. I have a ton of material, but most of it is so choppy because I kind of started on a path with it and I found some other things that I didn't like and I started over again. Long story short, this is not going to be a nice linear video of how to align a Model 2200 Panasonic radio. Now, I do have another one that's actually a 2900, and other than the case needing some cleaning and so forth, the inside, famous last words, looks to be a little more promising than this one was. The alignment of this is unbelievable, especially with my bench the way it is. I normally don't ever have these problems, but trying to align this, doing a visual alignment with test equipment is very difficult. And the reason I say that is whenever you try to align a radio like this, there's no shielding in it at all in the back. And all the components are kind of scattered around all over the board in there. And just putting your hand anywhere near it causes immense amounts of interference. In addition, you know, the HP8657, you know, and the entire series of these types of signal generators, I mean, they're laboratory grade signal generators. They're good quality. And even with this, just connecting the ground, the common of this, to the radio causes an enormous amount of AC interference from your mains line. And this is something I normally don't have when I'm doing a radio alignment. But this radio is just so sensitive to things like that. So you kind of have to do the alignment somewhat by ear and somewhat by visual method to get it to come in. I never was able to get good performance out of shortwave 5 and 6, which is the 20 to 24 megahertz and 24 to 28 megahertz, which really isn't a big deal because there's not a whole lot in those two bands. So I'm not really concerned about that. The other bands are performing very well right now, and I'm actually pleased with the performance of this radio. The switches are absolutely horrid on these. They're very flimsy. If you don't have the back screwed in, like if the back doesn't have all the screws in it, what you're going to find out is that as you try to rotate this, it actually, since it uses a coupling like this, it's almost like looks like a screwdriver blade and a screw, and it's spring loaded, it'll actually cam out and this will slip. And this is because there's no structural support for the circuit board other than when the back cover is on and the screws are in tight. So when you have the back cover off to do the alignment, what you're going to find is that as you try to turn this, it's going to cam out. So you have to kind of push on the board with your fingers and turn the knob. It's just not a very service-friendly radio. And I'm not saying this to complain or anything, but I'm just kind of giving some of you a warning out there that if you're going to work on these, understand that you're going to be met with some of these challenges on this. Now, if the radio's in really good condition and nobody left the batteries in it and got corrosion and things, you may not even have to do a lot of these things. The alignment's not going to really change on it. In addition, here's another thing I found. And again, I'm just giving you a primer to this video. I'm going to just sift through all my previous clips that I recorded and try to stitch them together to give you a few pointers on what I did in this video. I did end up recapping this, and I'm very thankful that I did because, and I think I have a clip where I showed some of this here, but if I zoom in a little bit with the camera, you can see that a large number of these have some pretty bad corrosion on the negative terminal. See, like this one, it's all green on the negative terminal. And then you can see this one is not. This one is still good. This one's good. This one leaked. You can, well, yeah, this one has a little bit on the positive terminal. You can see it. Just, I don't know if I can get in close enough that you can see it. Just a whole bunch of these are bad. Here's one. This one's really kind of leaky. And you can see the negative terminal on most of them that failed is the one that goes. Now this one, both terminals are bad. See, they both have that green. They just pee down their legs, you know. Need to put a diaper on them. So I ended up recapping, and it didn't really help a whole lot, although it did get rid of the poor audio quality. The audio quality on this was really bad. It almost sounded like you had a tear in the speaker cone, even though there was nothing wrong with the speaker. It just gave it kind of a distorted sound, and I think it was partially because of those capacitors. The switches are just horrible. You can't just spray them and clean them. You have to disassemble them to fix them. I do have some clips where I show the switches being disassembled and cleaning inside there, and you'll see what an arduous task that is. You can't get to half of the circuit board because the entire tuning assembly, and this one's out of my parts donor, this whole thing mounts inside there in front of the board. So you have to disassemble all of this. It's not as big of a chore as you might think, but it still is a little bit of a chore to take that out. Just a lot of issues, a lot of issues. The adjustments are very, very touchy. I think some of the ceramic capacitors that they're using for the, for frequency and so forth, one of them, at least for the shortwave 3 and 4 bands, had drifted, and we had to put a different capacitor in there to get the dial to track. It tracks perfectly now. But yeah, this was a real challenge to work on. And I have never worked on one of these RF-2200s. I've worked on a lot of Panasonic radios, and I love them. Some of them can be a little bit tricky, but usually the only problem you have with the smaller ones is the tuning capacitor will get messed up sometimes. You have to either clean it or replace it or something. But most of those, the radios usually are very reliable. Once in a while a capacitor or something, but nothing major. This one, though, I'll tell you, this is in a different class. So I learned a lot, though. This was very, very good education. So, well, I just spent how many minutes talking to you about it. Let's play the radio a little bit. You can hear it perform because it's in the evening now, so we should be able to get some things. And then we'll go ahead and go through what video content I recorded, and I'll try to put something together to show you some of the things I did. This, again, I wanted this to be a video showing how to do the alignment on this radio. You've seen me do alignments on shortwave radios many, many times before, but this one's a little different, and I thought it would be kind of interesting to see, especially with the crystal markers and so forth. But, well, I ran into way too many problems, and I had to kind of hit the reset button, So let's check it out, and then I'll try to put some material together, and I'll get it posted. Okay, to get the tuning assembly out, the first thing we want to do is start on the back here, and you have 1, 2, 3 screws here that are on these little cushions, the little strain reliefs. There's a 4th screw up here that comes out, and you can see I marked those with red paint, and I marked the heads of the screws also with red paint, just so I remember where they go. Before loosening anything, I set the dial. For my case, I had to set it exactly to 45, or to 45, like that. See where there's 40 and 50 on the log scale, and sorry, like that. so that I have access to the screws underneath there. And I marked down where I had it set. So I have it very accurately set on the 45 there of the log scale. And like I said, I wrote it down on there and made a note. Then I'm not going to move the tuning gang after that. I'm then going to go ahead and loosen these two screws, and I'll do that last after I take these. Now the front, I marked these screws with blue paint just so I know where they go, because you know it's easy to forget all this stuff when you get everything tore apart and there's a million pieces all over the bench. And then you're like me, you have to go to work, and it may be days or even a week before you get back on the bench. You want to mark things like this so you don't forget. So I'm going to take these screws out just like so. And then last but not least, I'm going to loosen these screws here. Hopefully I can do that on camera for you. Let's see if this screwdriver will even reach it. Nope. So let me try a different one. I'll be right back. All right, and hopefully we won't have to try to realign this. If we keep everything from moving while we do this process, everything should go right back into place. So let me loosen this screw here. Okay. And I think that should take this whole unit out, hopefully. I'm going to have to take this off. Let's see how I have it. Take that off because the light is connected. Okay, I had to take these three out as well. And then this should come right off, I'm hoping. Let's see. It's kind of stuck on that shaft. There. Awkward as an ostrich in a porta potty, as they say. Alright, so I'm going to leave this. I'm not going to move anything, and I am going to put another reference mark on the shaft here, just so we know. So, give us an idea of where we need to be. Okay. Now the first major issue we have with this thing is that it really does not is not very good to work on, because everything is coated in wax on this one. This is a little newer one. If you look at the parts chassis that I have, although they're very similar, you can see they didn't go nearly as bad with the wax. I mean, you look inside here, it's pretty clean. You look inside the newer one that I have here, and it is just saturated with wax, which is a major pain in the butt, because that's right where we need to work. So that's the problem. And of course this thing is dropping parts all over the place as well. So there. So yeah, we got our work cut out for us. So the first thing I want to do is I want to take this shortwave band select switch out of here. And the reason I want to do that is because the switch is just terrible. Shortwave 1, which is one of the strong ones that works well, just drops in and out, and if I wiggle the switch enough, it'll come back in. And that's strictly because the switch is bad. It's just all these switches are terrible in this thing. So I don't know if I'm going to have to pull the old one out of that other one, or if this one's going to be cleanable. This does not appear to have the all that terrible corrosion in it that the other switch had, but heaven only knows. So let's get it out. We'll get it apart. We'll look at it, and we'll assess the situation. So the first thing we have to do is get the wax off of here, and that's what I'm doing right now. And I'll kind of just show you how I'm doing it on this side at least. Just use the heat gun, wait till it melts pretty well, and then just sop it up with a paper towel. And it'll get it down to the point where you can actually get in there and work with it. I guess if we need to, we could put more wax on it, but I don't really see a purpose over here why we need to do that. I think somebody got a little bit happy with the melted wax in the factory here. I could see on the other side where there's coils and things that if you move the coils it changes the alignment and so forth, but for something like this I don't know. Now, as I said before, this video is a total redo. I started doing the alignment of the IF and so forth, and I just got to the part where we were going to do shortwave, 5 and 6, and proved that it was pretty much not working. I was going to just forego that altogether, but then I thought to myself, it would drive me crazy knowing that it doesn't work. I want this thing to work if it can. We don't know that it's 100% going to work, but I don't know. But we're going to do this switch first, and then I'm going to show you on the schematic why, or at least the section of this circuit that would cause shortwave 5 and 6 not to work, and shortwave 1, 2, and 3, and 4 to work perfectly. We'll look at that here in a little bit. Okay, the board is completely out of the case now, and I can give the case a proper cleaning, which I think it really needs. I removed this switch, which is probably one of the worst things I ever had to do. I mean, look at all those things. Without an actual desoldering station, very difficult. Even that, I had to use a little bit of solder braid. It just was a pain. But we got it out, and now I can get in here to look at some of this. I really want to check why that band is not working. Let's look at the schematic now. And you have to forgive the voice. I'm finishing up having a cold. It happens at this time of year. And I'm over it, but still talking like a frog every now and then. Anyway, let's look at the way this works and see if we can figure out what's causing this problem with the shortwave 5 and 6 not working. Now, if you look on this side, you have switch 2, which is that great big switch that we're looking at right here. And there's one set of contacts here and a set of contacts here. And what they do is they select the different RF for the antenna matching. So this is your RF adjustments here. And if you notice, there's a coil and a capacitor. So for the low side of the dial and the high side of the dial. And there's 6 of them. 1, 2, 3, 4, 5, 6. One for each band. Now, when it comes to the oscillator, as we said before, this is a dual conversion shortwave radio, meaning it has a 1.985 megahertz IF, and then they mix that down to a 455 kilohertz IF. So they do it in 2 stages. That gives you better selectivity. And the way they're doing this is they're using 3 different tank circuits for your oscillator, for your local oscillator, for the shortwave. So you have this first one, which you can see, and if I zoom in a little bit more there we go. We have shortwave 1 and 2. So you can see there's the selector switch along here. 1 and 2, 3 and 4, 5 and 6. And if you notice, for 1 and 2, these are jumpered together. So when you select 1 and 2, you're selecting this one tank circuit. And it's just using, by having the coil and the capacitor be adjustable, you adjust your high side and low side. So shortwave 1, for instance, would be more influenced by the coil, and shortwave 2 by the capacitor. Same thing with 3 and 4, 5 and 6. So we know that these two work and these two work, but these ones do not. The only thing that is common to 5 and 6 that will cause them both to fail the same way is this local oscillator right here. So what can it be? Well, it could either be a trace on the board, which I didn't see anything wrong. It could be this switch, which already is bad because when you select shortwave 1, you have to jiggle the wire back or the knob back and forth to even get it to quiet down. And I've sprayed and sprayed and sprayed. It just can't get it all clean. And you can see, if we look very closely in here, I don't know if I can get it to focus, but if you look very carefully here, I don't know if I can see, there you go. See the little tabs? There's little slides that go on there. So when I move this, you know, when you roll this around, that's going to select, it's just going to short out these little tabs. And you can see how cruddy they are. So they really need to be cleaned off. So I'm not going to disassemble this because all those little tabs will fall out and it's very difficult to get them back in. So we have to work with this together. So what I'm going to try to do is get in there with some cleaner and really clean it well, and hopefully that will fix our problem. So that's what I'm going to do there. In addition, I'm going to really look around this tank circuit here. So I'm going to look at what is this, L17? Yeah, L17, which is on the board over there. And remember, with that dial and with the radio in the frame and everything, there was no way to get to any of this. You have to totally disassemble this radio. This is one of the worst radios you can work on. If you're new to this hobby, stay very clear of these radios. They have a lot of problems with the switches. They're very difficult to service. There's little parts that'll break very easily. Just not a good beginner's radio. So I'm going to check these coils, and I'm going to check these capacitors, and I'm going to check all of the traces going to them, and I'm going to clean this switch and check it for continuity, which I'm not really sure which terminals go to what, but we're going to figure that out too. Well, I didn't really want to have to do this, but you could see that sticky crud that's in there. You just couldn't spray that out of there. It just has to be cleaned this way. So I took it apart. We're going to try our best. Okay, after some Brasso and a makeup applicator, this is what I used, and it cleaned right up. Even the leads came out perfect. So now all I need to do, and then I got all the gunk out of here, so all we need to do now is reassemble it, and it should be ready to go. And I'm going to put a few drops of deoxit red inside here, and then on the edges I'm going to put some grease, some lithium, and should be ready to go. Well, I guess it's a good thing I decided to recap this. These ones were still, at least you could see, visibly good. Every one of these were starting to pee down their leg already. I mean, if you look, you can see on the negative terminal there, the green. And then this one on the positive terminal. On this one, the negative terminal again. You can kind of see it. Excuse my messy hands from doing all this. This one, the negative terminal again. This one, the negative terminal. Alright, so after going through recapping and taking this all apart and cleaning the switch and all that stuff, moving all the components around, I'm sure the alignment's going to be at least somewhat out of adjustment. So we're going to go through and do the alignment again, and the other reason we're going to do it is because I already did it in the first video, but I want to show it. And first thing you have to understand, the first step they have you do is the medium wave or the broadcast band AM. alignment. And you're going to do the RF, you're going to do the intermediate frequency first, which is your 455 kilohertz. And that not only is that the IF for the AM broadcast, but it is also the second IF for the shortwave. So we want to get that set up first. And the external antenna jack, and I'll show you the back of the radio, there is an external antenna jack, and it says AM, but it's AM for shortwave. This antenna jack does not work with broadcast. It only works, the only antenna that will work is the bar antenna. So anything that we do on AM broadcast, you have to radiate the signal into the bar antenna. So that's all I have. I just have a loop of wire connected to the signal generator, and I have the signal generator set to 455 kilohertz. I have a pretty strong signal right now. And then I have a little adapter that I made that I use. It's a 1/8" earphone jack plug, I should say, and it goes to a BNC connector, and then that just allows us to directly send the audio to the scope so we can monitor it. So that's all we're going to do. And the scope is connected, and you can see I have the radio turned on, and I have all kinds of static right now. So we're going to get working here. Okay, so I have my signal being radiated in. Let's turn the radio, we're set to shortwave right now. Let me switch over to AM. And there you can see the signal. Now, here's the first thing. And let me go to AC coupling and bring this down. Okay. So first things first. Turn the volume up a little bit. Now the first thing you have to understand when you align this radio is how terribly sensitive it is to capacitive coupling. There's no shielding on this radio. It's not like a real high-end, ham radio, or it's a radio, just a plain old radio. So if I put my hand in there, you see, see how all that noise, all I'm doing, if I can back you off here, all I'm doing is I'm going like this, and just by putting my hand in there like that, it's introducing all that noise. So you can see just what I just did. I'm not touching anything, I'm just putting my hand in proximity. So when we do this alignment, we have to be careful that we're not injecting our own signal in there capacitively from our body by getting our hand too close. So we're going to have to use alignment tools that keeps the hand away, and we're going to have to remove our hand and the alignment tool to see your final alignment. And it's a little bit touchy to do it that way, but really if you want to get this thing to be accurate, that's the only way it's going to work. Okay, we want to align transformers 3, 4, 5, 6, and 7. They're all in this area here, and it's going to be this order: 3, 4, 5, 6, and then 7 down here. So I'll zoom you in so you can see them a little more closely in case you want to do this on your radio. So 3, 4, 5, 6, 7, and all we're doing is we're tuning for maximum peak at 455 kilohertz. So I'm going to, like I said, I'm going to start with this one. Notice I'm using a very long tool so I can stay away as I'm doing this. And this radio is just super sensitive to that. And the bad thing is the back of the radio is plastic and there is no shielding on it. So you just have to be aware of that when you're doing this alignment. All right, let's get up to the scope. And I will try to work around the camera, and we'll take a look at what happens here. So you can see I have a little bit of static on there, and we want a weaker signal if we can. I'm going to turn the volume up on the radio fairly high, and then I'm going to set the scope to be able to see that. And then I'm going to turn down. See, if I go up in amplitude on my signal, see how it clears up? But we want some static in there. Not too much, because then it gets too hard to see, but just enough. All right. So let's do those 5 adjustments now. And they should be pretty close, but again, they can be a little bit out. See there? And there's not a whole lot of adjustment, so we're going to have to drop our signal a little bit more. That might be too much. So let me change that. There. That's good. All right. And that's going down, going up, going down again. So right there's our peak. Okay. That's T3. Now to T4. Down. Yeah, that's pretty close. So 4, 5. Okay, that's right on. And I would expect these all to be pretty close. 6. And that one was pretty much peaked. And then 7. That one was a little bit off, I think. Nope, there it is. There's the peak. Right there. And it actually helps to connect a analog meter to this as well, like a VTVM, because it will average out that peak and allow you to see it. So I'm going to do that right now so you can see what I'm talking about with that. Okay, looking at the scope, you can see I put a Y adapter on there so I can connect both the radio and the output to the meter on there. And then we're going into the meter, you can see, and this is what we have. And that makes it a lot easier to check this. So let me go back to that alignment. It's dropping, going up, dropping again. So right about there is our peak. Okay, next thing we're going to look at is the BFO, or the beat frequency oscillator. And the purpose for that is to allow us to be able to listen to Morse code, or CW, and also to be able to tune in single sideband. And the idea is that BFO is a 455 kilohertz oscillator. So we want to set it to be exactly 455 kilohertz so that it will be in step with the local oscillator of the receiver. And they essentially will cancel each other out. And then any signal that deviates from that 455 IF frequency, which would be audio, will generate what's called a beat frequency. Now it's important that the local oscillator and the BFO are exactly in tune with one another, or it will limit the way that you can receive sideband and so forth. So if you notice in the first video, single sideband was very difficult to tune on this, and it will be because of the design of these radios. But if your BFO is not perfectly aligned, it makes it even more difficult to tune. Now, you have to leave this radio on for a minimum of 10 minutes to let it warm up and stabilize, because the BFO on these is known to drift because of the design of it. So it has to be on for a while for it to stabilize. This one has been on for that long at least, if not longer. So we can go ahead and adjust it. So the first thing we're going to do is we're going to go around to the front of the radio, and we're going to turn the BFO switch on, which is right here, right next to your power switch. And you can see already we have a pretty low signal. And let's adjust it. And what we're going to do is we're going to adjust this adjustment right down here, which is L30. That's the BFO frequency adjust. So what we're going to do is we're going to adjust for a nice flat line. So you can see if I go the wrong way, and the idea is to get it to minimize. And you're never going to get it perfect, but you can get it pretty close. Oh, went through it. And that's about as low as you're going to get. There. That's minimal. And now you're just looking at noise right now. And there you go. Okay, so the BFO is adjusted. Again, it's a very touchy adjustment, and it's just the way this one works. Some of the higher end radios have adjustable BFOs on the front and so forth. They're much more accurate. This one, it is what it is. Okay, we're now going to do our dial accuracy. And the instructions tell you to set it to 550 kilohertz, but you don't really have a 550 kilohertz mark on the band scale that's easy to see. So I'm going to use 530 because my signal generator can go there. So what I'm going to do is I'm going to set the dial very, very, very accurately to 530 kilohertz, which I've done. I'm then going to radiate a 530 kilohertz signal into the radio. Turn it around where we can get to it. And make the adjustment using L5 and L6. And L5 and L6 are down here. So L5 and 6 is going to be, there's L5 right here, and I believe L6 is up in the radio, or in the antenna itself. So there's actually an adjustment inside the coil, or inside the bar antenna. You can adjust the slug in and out of the coil, and that will fine-tune that. I think that's going to be pretty close. Nothing moved in there, and it's factory set. So we're just going to make sure that L5, our local oscillator, is set for the correct frequency, and already I can see that it is. So there it is, and you can see I have a nice signal. And if I move L5 at all, it's probably going to go way off. This thing's hard to turn. There. See, I'm going off frequency. And just, we want it to clarify. See how it gets clearer? So now I'm looking at the scope as much as the meter because I want it to be clear. And right there. That's about as close as we're going to get it. Now we're going to look at the high side of the dial. And for the high side of the dial, we're going to set it to 1500 kilohertz. That's where they want it, which is right on this first mark right here, right between where the marks get further apart and closer together. All right, and turn the radio back around, and let's dial in 1500 kilohertz or 1.5 megahertz. And you can see we're off, so we're going to have to adjust that. So buried under these wires we have our oscillator trimmer for 1500 kilohertz. That's what we're going to adjust, and you can see we're way off. So let's get on that and see if we can bring it on home. Okay, here we go. going the right way or the wrong way? I think I'm going the wrong. There we go. There we go. Right on frequency. And you can see that's not, you're not looking for peak now. We're looking for a clean signal. Okay, and then we have the antenna trimmer, which is over here. I'll show you. It's this little capacitor right here. We're going to adjust that as I make you dizzy moving the camera all around. All this stuff's in the manual too, and I've posted this manual on my Patreon, so you can all. Okay, so we're just trying to adjust this for peak. It's very touchy. I'm going to add a little bit of signal strength so that we get a little less bouncing of the meter. We're just going to see. And that trimmer capacitor is noisy, so we're going to have to be kind of careful how we deal with this. Once I pass through it, you can see it jumps. It's very, there it is. Stop. So we're right on it now. I'm right on the edge. That trimmer capacitor is quite noisy. Alright, I'm going to have to play around with this. I don't want to waste all your time, but all I'm going to do is go back and forth with this trimmer capacitor until it peaks out. Okay, then that's about as high as we could get that. Looks good. Okay, now the next thing they want us to do is align the second IF, which is only used for shortwave, and that intermediate frequency is 1.985 megahertz. And it's important that we get this thing set up properly, and they want you to connect it through a 10 picofarad capacitor. You can see that, a coupling capacitor, and you're going to need a really strong signal because of that, because they want you to very loosely couple it. And so that's what we're going to do, and we want to find a point of low interference, which the whole thing has interference with the covers off and open on the bench, but and what we're going to do is we're just going to drive the signal until we get something viewable on our scope. The first thing we're going to align is going to be the oscillator, and that's L4, which is this right here, I believe. And then we have to adjust 13 and 14, which are the two adjustments here and here, right next to this switch. So let me get you over to the meter. Okay, so L4, this is our oscillator for the second IF, and I have a pretty strong signal right now, and that's what we need going through this capacitor like this. Oh, that's the wrong way. There we go. That one was out a little bit. And the idea is we want this to look as clean as possible. I'm going to go up a little bit in amplitude with my signal. That's too much. One thing about this meter is this signal generator is you have to manually type in sometimes because the steps are too big. All right. So that's signal's getting dirtier, cleaner. Dirtier on the other side, cleaner again. And that's what we're looking for. We want as clean a signal as possible. There we are. Now we're going to adjust the other two for peak. So let me get on the first one. This is L13. That's going down. Going down. So we're pretty much peaked there. And L14. And that one seems to be pretty well peaked too. I'm using my meter now instead of the scope. Just looking for peak. And there we are. Okay. So that's done. Okay, this is kind of a different way of handling things. So you won't see this procedure in most radio alignment procedures. And that's called the padding alignment. Now, padding is something that you see all the time in radios, but what you don't see is the way that they do it on this one. Normally, when you look on top of your tuning gang, so right here is your tuning capacitor. So when you turn the tuning knob, this is what you're adjusting. You're making these fins go in and out in, more or less capacitance. And usually there is a padding adjustment, these little screws across the top that you would adjust with little mica trimmer capacitors. And that's what you use to set the dial accuracy. So what will happen is if those are not set properly, the dial might be accurate at one end, like at the low end, but it'll be inaccurate at the high end, or vice versa. So getting it to track linearly, you need to use those padding capacitors, and they're just little trimmers you would adjust. This one does not have that. They actually used a fixed value capacitor, and if you look, there's 3 of them for 3 different band ranges, and I'll show them to you here. This green one, this Mylar capacitor, is for the lower bandwidth. And then you have this ceramic capacitor here and this one here. And you can see they're on standoffs, little posts that stick up from the board. You can replace these. And there's a chart. So what you do is you're checking the dial accuracy, and if it's off, you are changing these capacitors according to the chart that they have in there until the dial is as close to being accurate as you can. And they have a kind of a novel way of doing it. This radio has a built-in 125 kilohertz marker. It's just a signal generator that puts out a constant 125 kilohertz, and you can switch it in, and it can actually interfere with your RF and IF circuit, and essentially whenever you're at a multiple or a harmonic of 125 kilohertz, you'll hear that zero beat come in. In other words, you'll hear this tone as your off frequency, and then as you go into the frequency, that tone will zero beat. You'll hear the sound will get real low and then go away. Then the sound, you get on the other side of it, the sound will come back and start getting higher pitched again. They're actually having you use that to verify that the dial scale is tracking. If not, they have you change the capacitor. So I'll do the procedure with you here, but this is the chart that they give you in the service manual. And you can see they have you look at shortwave 1, 3, and 5. And you start at 1 frequency, and you get it to 0 beat there. And then you turn the band spread dial exactly 2 times, and I'll show you what they mean by that. And it should stop right at 6 megahertz. It should 0 beat. Okay, so you go 0 beat after you turn it 2 times, and you should be exactly on 6 megahertz on your dial scale indicator. If you're not, then one of these capacitors is wrong. And it says, depending where the spread dial ends up being, when you 0 beat, this is the value you have to change the cap. So you can see there's 4 different choices for each one. And I did have to set 2 of them. The first one was dead on. The second one was off by quite a bit. The third one, I wasn't able to test because, again, short waves 5 and 6 didn't work. So I tried just replacing them with the same value, thinking maybe there's something wrong there, but didn't help. So hopefully it will now. So let's go through the process, and I think you'll get a better understanding once I do this one time. Okay, for the first one, we want to start, and there's no signal generator used for this. There's no external test equipment other than I'm using my scope to monitor the zero beat, and we'll look at that in a minute. So we're on shortwave 1, and we're going to turn the marker on eventually here, but what we're going to do first of all is we want to start out at 4 megahertz. So we're on this scale here. We're going to rotate this down to 4 megahertz, and we want to get right on it as close as we can, and we're going to use our marker till we get zero beat. Okay, and we should see something there, and I'm not seeing it right now. Okay, for some reason our 125 kilohertz crystal marker is not working, but the 500 kilohertz marker is. So if you look here, I go to 500 kilohertz marker, and if I tune through this, you'll see that I'll go through that zero beat. And let me show you on the scope here. All right, so here we go. So right now, you see we're just almost on zero beat. I'll go above, so I'm tuning clockwise now, and you can see it goes to a beat frequency. I'll go counterclockwise. That frequency will get lower and lower. It'll disappear, and then it pops on the other side now, and then it'll get higher and higher. So the idea is we're right about there is your zero beat. That's about the best you're going to get, because again, the tuning capacitor is not that accurate. So we're right on 4 megahertz right now, perfectly. And you can see our dial is pretty accurate at 4 megahertz. Now, before we can do this procedure, we really need to get this crystal marker to work. But let's just use the 500. I'll show you the process. So what they want you to do is they want you to rotate this knob. I have it set to 0. There's a lock on the band spread. So when you hold this 500 down, it'll drop into a notch, and you can lock the band spread knob at 0 and then set your frequency for your beat frequency. So we're there now. And then what they want you to do is rotate this 2 times. So there's 1, 2. And if I go back down here again, I should be just about at my zero beat. And sure enough, right there it is, right there. Right there. And what they're saying is we should be at 6 megahertz. You can see we're right directly on the notch for 6 megahertz. See the little notch there, the scale? So we're right there. So dial accuracy is very good. Now, what we should look at is what they're saying is it should fall on the 0 again, and it does almost perfectly. And that's because that capacitor in there is correct. Now, what they're saying is if this band spread dial lands on one side or the other, depending on where it lands, so for instance, if it lands on somewhere between 960 and 980 kilohertz, which would be this direction, on this direction, they would have you change the capacitance to 1,000 picofarad. That's what they're saying. The one that's in there right now, though, is correct, so we don't have to change it. But before we do the next one, we need to make sure this 125 is working, because again, this is going to give you more accuracy with your adjustment, and we want to see this work. Okay, two problems. First of all, this schematic is rubbish. This is an older design, and apparently at some point in time Panasonic changed the design of this. This whole section is no longer in existence. There's a mystery chip, which is a what did I say? It was like a 54018 or something like that, that doesn't cross over to anything. And all of the diodes and everything are just not there. Like D27 through D36 are missing, but we have D37, and we have a new set of diode numbers that are not on the schematic. So this whole oscillator marker section has been reworked by Panasonic. If I connect on this diode here, I can see the marker signal, and if we look up at I don't know if this, without really moving the meter a lot, or moving the camera, well, let me adjust it. There we go. If you look at the signal, at the frequency counter, it's pretty daggone close to 125 kilohertz. So I have to think that there's some other reason that we're not getting our marker, our 125 kilohertz marker, in mixing into the signal. So I'm going to have to look at why this is not working, and I'm going to have to try to find an updated schematic for this. Okay, I don't know what that was all about, but the 125 is now working perfectly. So I turned the radio around, I looked at it, measured it, and all of a sudden now it's working. So who knows? Maybe a wire got moved or something. But if we look up here now, again, I just have the 125 on. I'm right on 0, where I was with the 500 kilohertz. And you can see, if I just ever so slightly move this, you can see I go through my 0 beat right there. And if I just letting go of the tuning knob, it springs back and pops. It's just so touchy, but we're there, right there, and we're right on, again, directly on 6 megahertz. So it's correct. But I do need to find the correct schematic for this. This is interesting. I didn't even notice that until I had to do something here with testing it. Okay, now that I got my head pulled out of my ass, we can continue on with this. The first thing is the good news. And the good news is all of the procedures, test points, and alignment points are exactly the same. So nothing is wrong with what we have been doing up until this point. However, there are three different versions of the RF-2200. Now, probably a lot of you are throwing things at the monitor right now saying you knew that, because you probably did. But remember, I don't work on I've never worked on a 2200. It's a new thing to me. So anyway, that's what you get for not doing your research, huh? So we've been working with this so far, this schematic, and you can see this divide by 4 network. So the oscillator oscillates at 500 kilohertz. You divide it down by 4, and then at the output you have your 125 kilohertz, and those are your 2 markers, okay, for all intents and purposes. And remember, in our radio we don't have that, and even in my parts chassis doesn't exist. And there's this extra integrated circuit that doesn't show up anywhere in the schematic, this IC3, which happens to be a Mitsubishi M54812L. The 54812L is, as you can probably guess, a divide by 4 circuit. And it takes the place of all these discrete flip-flop components. And doing a little more research online, I was able to find the proper service manual. Now, The RF-2200 and the RF-2200BA look to be the same circuit. They all have this circuit. The BS, and this is a bunch of BS, isn't it? The 2200BS has one difference, and there it is. It's our chip. And looking at the back of that diode that I was looking at, well, that's the waveform I had, and it's exactly what it's supposed to do. So this circuit is working. I don't know how we got on a wild goose chase that I couldn't get the 125 kilohertz to work, but it stopped working briefly. I turned it around, figured this out, flipped it back around, and now it's working. So I don't know. We'll see what happens. This is going to be one crazy, really crazy video. So anyway, now that we got that straightened out, let's go back to what we were doing. And we're checking once again the padding alignment on the tuning capacitor. Okay, so we're back to this. And by the way, the procedure and everything, all three manuals is the same. They haven't changed anything on it. So let's go back. Now we proved that shortwave 1 is perfect. And that's the one that has that Mylar capacitor. Now, the next one we're supposed to go to is shortwave 3. And we'll go to 3. I'll turn the power on. And same thing, they want you to start out, for this one, they want you to start out at 12 megahertz. So let's do that. I'll go to 12 megahertz. I'll get you here in the screen. So we're going to crank this down to 12 megahertz right here. And somewhere in here we should have a chirp. There it is. And we can just use this even, and then I'll just show you how that works. So there it is, right there. Okay, oh, right there. And again, so we're right on it. So there's your 12 megahertz, you can see. And again, we want to set this to 0, so we can 0 beat it. And you can see where it dips, right at that dip. Okay. Okay, we're right on it. And this is set to 0 once again. And again, they want you to go 2 times from 12 megahertz. Okay. So we're going to go 1, 2, and let's see where we are. Right there. It's not a really well-defined chirp there, but we are getting it. I'll show you what I'm seeing on the meter over here. As I pass through it, right there's one side of it, right there. Whoop. Right there. And if we look, once again, I should be very close to 0. And in fact, we are. You can see where the 0 is right over here. And we're right on 14 megahertz, which is what we should have. And again, we're within that 20 kilohertz range, so it's good. Okay, for the shortwave, I'm only going to do the first band. There's 6 of them. It's the same thing, just different adjustments. But you basically do the same thing. You set the signal generator to the frequency they ask for, adjust the appropriate control, and peak the signal. And of course you're looking at the oscillator, for the low band, and the capacitive trimmer for the high end of the band scale. And that's all you're doing. So I'm already set to have the dial face on here set to 4 megahertz. I'm feeding directly into the shortwave antenna jack through a 10 picofarad capacitor. Now, because they request this, you have to have a pretty strong signal out of your signal generator because of just how much attenuation you get from this capacitor right here. So, and they only want 30% modulation, so you're not really driving it very hard. So we're going to put that in there, and I do have the headphone jack, you can see, coming out of there, and it's going up directly into my oscilloscope, and that kills the speaker so you don't have to listen to that tone be so loud. And then I also have a splitter on there, and this other wire goes to my bench test speaker, which you can almost see sitting behind the VTVM. See the grill of the speaker? And that just allows us to monitor the volume quietly without blowing your eardrums out, but you still turn up the volume almost all the way like they want it. So you can see that's almost the volume maxed out. You can just hear it right there, and we can actually visually see the waveform as well. Okay, the signal generator and the radio dial are both set to 4 megahertz, and what we want to adjust for the 4 megahertz is L15 for the oscillator and L7 for the antenna trimmer. I'll show you on the parts unit radio. I can show you where those controls are because I don't want to move the camera. But if you look here, we're going to be adjusting this right here, which is the L15, and then we're going to adjust L7, which is right here. So L7, L15. All right. So here we go. L15. You can see I'm going the wrong way. And right there's peak. And you can see it was on peak to begin with. And then we're going to do L7, which is this one, that one I showed you. Oh, that was a little bit off. See that? Got a little more amplitude out of there. Okay, so that's done. Now we're going to go to 8 megahertz. So we're going to set the signal generator and the dial face to 8 megahertz. And we're going to just do the same thing. Okay, we're now at 8 megahertz. And for this one, if you notice, I marked 2 other ones in blue. And that's going to be the capacitor right next to that coil we adjusted. So that's going to be this C112. And then up here, just above and to the right, we're going to adjust C85. And we're going to, it's the same process. You're just looking to peak the signal out. So let me get around the camera here. And I think it's going to be pretty close. And see when I put my hand on the radio how much it affects it? So a lot of that jumping is just my hand coming close to the radio as I adjust it. And you can see I went off, and I'm off there. Very touchy. And there it is. And then we're going to adjust C85, which is this one up here. Okay. And doesn't make a huge difference, but you can see how it starts to jump a little bit as we adjust it, but that's about it. And like I said, this was pretty close to being on before. That's it. Now looking at the instructions, you can see this is all the same for all of them. So we just did shortwave 1, but 2, 3, 4, 5, and 6 are all the same. You have your low end of the dial, high end of the dial. And that's all you're doing. So that's it. And you do that and your radio should be working at top performance. Okay, last thing we're going to do is we're going to check the FM. And I can tell you right now, we're not going to have to do anything to it. I am in the basement, surrounded by all this equipment. I am at the bottom of a hill where I live. It is notorious in this area that you cannot receive FM anything. I have no antenna connected. I have the coax cable for the signal generator is the only connection I have. I have the antenna all the way collapsed and listen.
Right. Again, we don't know the specific situation, but I'm guessing it doesn't sound...
Yeah, I'm picking up stations. This thing is unbelievably sensitive. I'm really only going to test dial accuracy, and I have a feeling it's going to be okay. So let's turn this on. We will inject 88 megahertz into this, and I should be able to hear my tone, and there it is, right on. Let's see how far down we can go and still get audio. There's 32 microvolts. It's getting 10 microvolts, 3.2 microvolts. You can still hear it. Nothing wrong with that. So there's 88. Let's go up to 108 and make sure that it's right on. So frequency 108 megahertz, and this is going to be a little bit weaker. No, the heck it is. There it is, 3.2 microvolts, 1 microvolt. You can still hear the tone. So FM is perfect. The dial accuracy is off by a little tiny bit at the extreme, but I'm really not going to concern myself with that a whole lot. It's not worth doing a whole dial scale alignment. I mean, it's like touching 108 just a little bit off, tiniest little bit. That's not going to make any difference.